Hello everyone. Last time we talked about half wave rectifier. So this video is in continuation to that video, part 2 of that video, and in this we will discuss about full wave rectifier. So basically full wave rectifier, they are of two types. One is center tapped rectifier and other one is bridge rectifier. So here this diagram is for center tapped rectifier. Why is it called center tap? Because of the transformer used. This transformer is called center tap because of this division. This center tapping allows equal division of voltage of the secondary voltage on both half of this center tapping. Let us see how it actually works. This is a complete cycle, a positive and negative. So here in the positive half cycle, what happens? That this is positive, this is negative. Here also it will remain same. And due to center tapping, equal division of voltage will take place here. If voltage V is there, then at center tapping V by 2 and V by 2 voltage will be equally divided. So here how it works, that when positive half cycle is there, this side will be positive negative. Again here also it will be positive negative. So due to this positive, this diode will get forward biased, and here due to this negative terminal, this diode will get reverse biased. Now we know that only when forward biased diode will allow current to flow. So this will be closed circuit, and here it will remain open circuit and will not allow any current to flow. So how the current will flow? Current will start flowing from here. It will flow through load, and you can see this closed circuit, and it will return to this point. So this is how current is flowing across this. So we can see that current through load is in this direction. You can see. Okay. So when we find the voltage across it, so we get a positive pulse here. So we get a positive voltage here during a positive half cycle. Now let's see what happens in the negative half cycle. Do you remember that in the half wave rectifier, it conducts only for one half cycle, that was positive half cycle, and so the power was lost in the negative half cycle. That was its disadvantage. So now in the negative half cycle, this will be negative positive, negative positive. Again here division will take place, negative positive, negative and positive. Now you can see this negative, due to this negative, this diode will be reverse biased and it will behave as an open switch. And due to this positive, here this diode will be forward biased and it will behave as closed switch. So now how the current will flow? Current will start flowing from here towards the load and finally to this point. The current will flow like this, and then again you can see that current load is in this direction. What we will get for the negative half cycle? Again this type of cycle. Okay, because direction is same. You can see the direction for the load current is same in both half cycle. So finally what will be the output? We can see that for both for positive half cycle and for negative half cycle, we are getting a positive pulse. So what will be the final outcome? Is we input, it is positive, negative, positive, negative. This is the output. So what kind of pulse you will get? A positive pulse for positive half cycle, again a positive pulse for another for negative half cycle. Again we get a positive pulse for positive half cycle and a positive pulse for negative half cycle. The same continues, and this is the final output we get from the full center tapped full wave rectifier. So how is it different from half wave rectifier? If you remember, the output of half wave rectifier was this. So here you are getting an output for each and every cycle. So this is one of the advantage, because here the power loss is less. Next is bridge rectifier. We'll talk about the advantages and disadvantages at the end, so that you can get a comparative analysis of half wave and full wave. Yeah, so second type of full wave rectifier is bridge rectifier. It contains 4 diodes here. in a transformer. Let's see it's working. Positive half cycle is what we applied, and I have taken a positive half cycle here, so this will be positive negative, positive negative, positive negative. Watch carefully. Now due to this positive, this terminal will get a positive voltage and this below terminal will get a negative voltage. So here you can see that this diode gets a positive voltage at the P side, so this diode gets forward biased. Due to this negative cycle, this get a negative, so it gets reverse biased. This diode T4 is getting positive terminal at N side, so this will give a reverse bias. And here negative terminal is connected to N side of the diode T2, so this will be forward biased. You can eliminate these two because these are reverse biased. You get no path from here because these will be open circuited. So what is the path you will follow? It will current will flow this way from the load and finally it will reach at this point. So this is how it will start from here to this, and this is how it will follow. So here you can see direction of current from load is downward. Okay, so remember, so here the cycle we get a voltage across load during positive half cycle. Now what happens during negative half cycle? This is what we get in negative half cycle. So this negative positive, negative positive, negative and positive. Negative voltage at this terminal, positive voltage at this terminal. Due to this positive, this will be forward biased, this will be reverse biased. Due to this negative terminal, this will be forward biased, and this diode D1 will be reverse biased. So eliminate these two diodes. This path will be open circuited, so it won't allow any current. Now what will be the path it follow? Now it will start from positive terminal. It will go along diode 3 from the load, then from the diode D4, and finally back to terminal, negative terminal. So this is how this path is being followed. So again you can see that current across load is in the downward direction. So again you get the cycle in the same direction only. So here this is very important point because you can check that the direction of current through load is in the same for both positive and negative half cycle. So we are getting output both for positive and negative half cycle. So final outcome what we get, again the same outcome. That's why we call it a full wave rectifier, because we are getting output for both cycles. So this is how these two types of full wave rectifier work. I hope you got a clear understanding of the operation of these two type of rectifiers. Now this is complete chart on half wave rectifier, center tapped and bridge rectifier. I have combine all those three in one table so that you can easily compare. We can see how these three are different. Full wave rectifier is better than half wave rectifier. So first point is number of diode used for 1 in half wave rectifier, 2 in center tapped and 4 in bridge rectifier. RMS voltage, this is how we represent them. DC voltage, this you can see that DC output voltage is twice in case of center tapped and bridge rectifier. So output is twice in case of full wave rectifier. So this is obviously good. Efficiency double actually. It was 40.6 in half wave and it is 81.2 in bridge rectifier. Ripple factor has reduced. I told you that ripple factor represent AC component. So we need less AC at the output of the rectifier. So this ripple factor is also reduced in center tapped and bridge rectifier. Ripple frequency is twice for full wave rectifier. Now again peak inverse voltage is twice for center tap, but it is same as half wave rectifier for bridge rectifier. This is the value for form factor, and transformer utilization factor is also improved. It is maximum for bridge rectifier. So this means bridge rectifier makes maximum use of transformer. Now I'm not going in detail of all these parameters because I have already talked about them in my previous video in half-wave rectifier. So if you want a detailed understanding, so please watch that video also. I will add the link in the description box. Now let's talk about some advantages and disadvantages of these full wave rectifier. Now first, for center tapped, we have seen that efficiency is almost twice and ripple factor has reduced. In center tapped, we saw that each diode was on for only 1/2 cycle. Other diode remains off, so that's why this output obtained is smaller. This is in comparison with bridge rectifier. Manufacturing center tap transformer is a quite expensive task. That's why this is expensive. Advantages and disadvantages of bridge rectifier. One of the major advantage of bridge rectifier is reduction in size and cost because of the absence of expensive center tap. Because you're not using center tapping here, so that's why this become less expensive. Now it has higher efficiency than half wave, twice, as we have already discussed. This is disadvantage. It is complex because you are using 4 diodes. A bridge rectifier has large power loss. So this is also one of the disadvantages of bridge rectifier. That's all from rectifier part. So hope you like the content. So please like and subscribe. Thank you so much. Bye and take care.